Hi folks, welcome back to Math with Captain Rod. I'm making this video to help you learn how to maximize or minimize functions, or let me restate it. Find the maximum or minimum values of a function over a given interval. So we're going to look at a couple examples here. I'm going to call this first one example 1 here. And here we have a function, and the highest point on the curve is right here, give or take. I'm going to put a dot on it. And that occurs at x equals about 1, 2, 3, 4, 5, 6, 7, 8, about x equals 9. So the max value is f of 9, which is about 1, 2, 3, 4, 5, 6, 7, which is about 8. Now, you'll notice that the red dot is higher than the two sides around it. That red dot is also called a relative maximum. Now, anytime you see something like a spot like this, like here's another one right here, this is also a relative maximum because this point is higher than the two spots around it, so to speak. You can probably guess what this point right here is called. This is called a relative minimum because it's higher than the two or lower than the two regions around it. A relative min or max may or may not be what's called the absolute max on the domain of the function. So this one right here is a relative max, but it's also the absolute max because on the domain interval for this example, it is the highest value. So a relative max may or may not be the absolute max. Now, as far as finding relative maximums, if you take a look at these examples, look at the tangent lines. Here, here, and here. And they all have something in common, right? Those tangent lines all have zero slope. So when you can use this fact when you are looking for relative maximums, you look for where the first derivative is equal to 0. So, if you have a function, you typically will differentiate it, set the derivative equal to 0, and then solve for typically x to find what x values give you the locations of the mins and maxes. Now, you don't always know whether you found a relative min or a relative max when you do that. So let's talk a little bit about what's called the second derivative test. If you take your function and you differentiate twice and you look at any given spot, so let's say we've done this and we found x equals a, some number is a relative max or relative min. F of a gives the value. Then to decide if it's a min or max, you can look at the second derivative. So if we take a look at this example right here, you'll notice that the tangent line slopes are decreasing. And you'll also notice that right here as well. See how the tangent line slopes decreasing left to right. So when your second derivative is negative, that would indicate you have a relative max. And you can probably guess the other one. If your second derivative is positive, you have a relative min. And it is possible to have something like this and not be a relative extreme at all. If your second derivative is 0, you have an inflection point. So an example of what would that look like on a curve if we did something like this. This point right here could have a first derivative of 0, but that does not guarantee it's actually a relative extrema. And you'll notice this point would have a second derivative that's 0. So as far as finding relative mins and maxes, you look at the first derivative, set it equal to 0, look for the values that yield the maxes, put those values into the function to see what the maxes or mins are. You can look at the second derivative to then tell whether they're mins or maxes or an inflection point. Now, a relative max, like in this case, may or may not be the absolute max or min in any given function. In this case, this relative max is the absolute max, and this relative min is the relative min. But that is not always the case, as we'll see in example 2 here. If we looked at where the derivatives were 0, in other words, where the tangent lines had 0 slope, that would be here, here, and here. So if we found that one is a relative min. It is also the absolute minimum on the interval that we're given. Whoops. Which is roughly this. This one is a relative max, but it is not the absolute max on the interval. This one is right here, that point right here. And that one does not correlate to any of the derivatives, basically. So, little moral of the story here is, when you're trying to optimize a function or find max and min values, you look for where the derivatives are 0, but you always check endpoints too. Check endpoints, because they can yield max or min values as well, and the derivatives won't tell you about the endpoints. So that's kind of a my theoretical video on how to find max and min values of any given function. I'll make some examples, I'm sure. Hope that this gives you an idea about how to do this. Have a great day.